Hello, my name is Andrey Styskin. I'm from Yandex and I would present to you our aggregated search. Let me check how to... why actually we need verticals and why generic web ranking is not enough? This is an interesting question because in our query stream we have examples of queries that are strongly means particular vertical intents, but there are 3 points. Some vertical results are not normally presented in default web ranking, for example, images. The second point is sometimes the goal of vertical search is very different, and because of that, specialized vertical ranking provide much better results. And the third point is when vertical offers special user experience. For example, maps vertical where you can navigate between the results using map. Okay. What are examples of verticals do we know? We all know image search, video search, product search, news search, and we in Yandex have more than 10 other specific for Yandex, I guess, verticals. For example, job search, people search, app search, car search, flight ticket search, and others. Let me show you some examples. This is, for example, people search, where you can find your friends or classmates. This is our app search, which is very useful on mobile phones and sometimes useful on web search. And I'm sorry for Cyrillic examples, but we don't have many of our verticals worldwide. Okay. Here the plot of vertical intent distribution, and we can see that there are a lot of examples and they cover a lot of queries. But the interesting fact that if we look on number of intents per query, then we discovered that different intents not much intersect between each other. So not more than for example, not more than about 10% of queries has more than one particular intent. And this would be reasonable for solution that we propose for aggregated search. The second interesting fact that intent popularity changes in time. For example, this plot shows that we have two intents, watch online and download intent, and I guess because of internet speed grows up with time, people want more to watch online and less to download content. Yeah, here are more examples. And these plots provide us idea that we should think that intent popularity changes and we should deal with this. And for example, this slide shows us if we solve the problem of aggregated search with web ranking, we should rebuild our formulas very often. Okay, let's address to the classic approach of aggregated search. They do as follows. They first off they do vertical selection to understand which particular verticals can be relevant for particular query, and after that they do block ranking. They rank blocks of verticals via blocks of organic web results for this, they use pairwise preference judgments, and the formula is trained on sparse feature space. Our solution differs. We use diversification principles, deal with query ambiguity. This ambiguity appearing when the need in specific vertical can be detected only with uncertainty. The scheme of our aggregated search looks as follows. We ask queries to all verticals, then get ranked documents for all possible intents. Then, since we know a lot of information about answers, about query, calculate intent probabilities for each vertical, and then build final result set by maximizing ERR intent aware metric. Okay, our solution is called Blender. Let's look at details of our solution. So we need two things. We need to calculate intent probability for each intent, and we need ranking for each intent. To predict intent probability, we for each vertical separately do 3 steps. We pre-select queries with minimum relevance to particular vertical. This helps us because the efficiency of judgments grows up. After that, we assign queries to categories. Categories are the query is strictly about vertical. The query in most cases is about vertical. The query has some chance to be connected with vertical results, and the vertical is not relevant to query at all. And after this manual assignment of categories, we learn to predict probability for each vertical So we machine learn this probability. For machine learning, we use set of features for intent prediction. As all people do, we use pre-retrieval, post-retrieval, and post-presentation features. And here I would provide some examples. Pre-retrieval features are, for example, we can look at specific keywords in queries. For example, download indicates that we have deal with download intent. We can see the presence of entities of specific time in queries. For example, if we know that we have celebrity in query, that helps us to understand that we would like to see pictures of this celebrity, maybe videos. Also, the strong features are the probability of vertical documents language model to generate the query, and the probability of vertical query stream language model to generate the query. Post-retrieval features are, for example, average scores of top documents in vertical ranking, and if we deal with time-specific verticals, for example, news, time distribution features helps a lot. For example, number of found documents in a day to all period ratio. And post-presentation features are like CTRs, average dwell time, or conversation on vertical results after building final result set. Conversations, this is interesting type of features when we, for example, for specific verticals, for example, for product search, the conversion is the event when user added the product to the cart. For video, conversion is the event when user watched until the end. Okay. Now we are able to predict intent probability for each vertical. Let's try to rank documents for intent needs. The easy case when intent need is equal to content type. For example, for images, for this case, we just need to build or use independent vertical search ranking. But sometimes content documents of particular content type are already presented in web ranking, and we are to deal with this. And for example, in the paper time is of the essence, improving recency ranking using Twitter data. They describe the method where we can use vertical specific features to improve ranking for intent need. We cannot do it in straightforward way because the vertical specific features are very sparse in compared to whole pool for ranking. Okay. Okay, so since we can build intent-specific ranker using documents from web search, we can build verticals for each type of content right upon big web base. For this, we need three things. We need classifier of specific content type. We need to define attributes for that type and mine them from documents. We can use microformats or own text miners to extract, for example, prices from pages to build product search. The next thing, we need to define vertical specific assessors instruction for vertical item relevance and label items, and yeah, machine learning the ranking model. If we don't have microformats on sites, we can use own mining scheme when operator can easily study the scheme of mining, and we for each site. And this is the example of interface when operator can using his mouth to indicate attributes that this is like prices, this is the name, this is quality of particular good, and we can mine these attributes from pages. Okay, how to evaluate our solution? We use ERR intent aware metric with abandonment, but we interpret it as precision to find answer in case of intent uncertainty. So ERR intent aware is sum of intent probabilities multiplied by ERR of particular intent. And let's decompose this ERR formula. So the final metric is sum of probability that user would see particular result multiplied by probability that this particular result would be relevant, and the probability that user would see the result calculated from cascade models. So user read results one by one. If he find relevant result, he stops his search and he continues searching if the previous result would be irrelevant, and with the probability of p break, he would stop the search session. Why I'm talking about this? Because we looked on eye tracking experiment. So we asked people to find some to do some search tasks, and sometimes we put in this experiment irrelevant vertical results, and we can see that users can easily skip this block of irrelevant pictures because they understand that this is pictures, they don't need it, and they clearly understand that they don't need pictures and can skip it. So this was quite interesting result, and we think that we should use this this experience to extend ERR metric, that we need extension that cascade model to skip blocks of vertical answers in case of irrelevance easily. Okay. How to build final search result page? We already know probabilities of intents. We already know relevances of results for each need, and we build final result page incrementally via greedy maximization of ERR intent aware, and after that we merge vertical results of the same type into groups, so that users can deal with group of results of the same type and easily skip it. Okay. Let's see to both approaches in comparison. So classic approach and Blender. For selection, in classic approach, binary classification is used. In Blender, we predict intent probability. For presentation, in classic approach, they rank verticals and web blocks and assign them into slots. In Blender, we generate results via maximizing ERR intent aware metric. For judgments, pairwise judgments are used in classic approach, and we use absolute judgments. They are easily to deal. I would describe it on the next slide. And for offline evaluation, in classic approach, similarity between predicted and optimal ranking is used, and we use intent aware metrics. Why we use Blender approach? We believe that it is easier to deal with such approach when we work on each vertical independently, because the task, our task is to continuously improve each vertical ranking and continuously improve search results. And people can look on bad examples, understand that their particular vertical, which deals with, for example, 2% of query stream, works not very good, and they understand that this is because there are not so many examples in training set for this particular vertical, and they decided to enlarge the number of examples with their particular vertical twice. For pairwise for classic approach, they need to do such big extra judgments to that training set would still be representative. But when we deal this independently, we need only small number of extra judgments. This makes sense a lot when we deal with news or freshness or social results as one of the verticals, because we need, if we develop new temporary feature, we need to rebuild whole training set, because we cannot take this feature in past, because we just don't have time machine. But when we deal with temporary sensitive vertical independently, we can easily do not so many judgments to get result. Okay. Final evaluation. Why we believe into ERR intent aware? Because we always check with online experiments. We can compare web ranking. We see aggregated ranking via A/B testing, and ERR intent aware better correlates with online evaluation metrics than ERR in case of queries where verticals are needed. And here are results, for example, for our new freshness vertical. So white P found is growing, abandonment raised down, STRs of recent results grows. Okay. But after we put our solution into production, we can still get information, we can get click feedback. So we use click skip metrics for each vertical, for each query or query type. So we calculate whether the position of particular vertical is low enough or high enough by calculating this click skip metrics. It's very simple formula, and we use this information in two ways. We correct parameters for blending for particular queries, and also we use the examples of incorrect types to improve assessor instruction and adding new features. These are two last slides. I took them from www 2012 workshop for aggregated search. These were short-term goals and middle-term goals in 2012 year. So what we needed to do in future from the view of 2012. We need to think about diversity in vertical presentation and attention modeling. So by Blender solution, verticals can be redundant, verticals can be complementary, and we evaluate whole page relevance when aggregating. And attention modeling, yeah, is a good question. We need to think more. Also, there were medium-term goals. These goals said us that we need to think not about just 10 blue links, but using all space of search results to deal with. Yeah, this is probably a good question, and And about detecting new verticals, maybe this is a good question, but we have the whole list of verticals to build next, because we can measure the query stream, and we can see many examples that are less than 0.1% of query stream. So I guess no automatically detection of the verticals that we should be in modeling next is not required. Okay, that's it.